just taking enzyme. We're just taking enzyme and you're diluting it, not adding any substrate. So here, whatever value you're getting is the background color which is there. It is not because of this. It is just, it is there. Okay, so it's a background value. So, and actually you guys need to subtract those values from your the other values. The tubes where you are getting the reaction, where you are having both the enzyme and both the catechol, there actually you need to subtract those values, because those values you are not getting because of this. Okay. And also you had, I think, third and fourth tube in which you had catechol, you had enzyme extract, and what you found in those tubes? You found that the values first increased, right? You started with like 0.3, then it became 0.5, 0.7, 0.8. Everybody had little different readings. 1, 1.2. So which means that the reaction was proceeding, right? So the reaction was something like, if you plot like this, if you plot time here, which is the independent variable, and you plot absorbance here, you should get this kind of graph. And after some time, like around 120 seconds or 150 seconds, it was leveling off. The values were not increasing. So it was becoming like this. So by doing this, what we are doing, we are studying the enzyme kinetics. We are studying how this enzyme is catalyzing this reaction. Okay, so these are very important points. You must understand these, only then you can write a good lab report. And this lab report, the nature of science does not matter much because it has just 10 points. This one is 7.5%, which means it's worth one class test. So please do this very carefully. So you were studying enzyme kinetics, and second thing what you were studying in this experiment is you were studying the specificity of the substrate. Because in your last tube, instead of catechol, you have used sucrose. And if you remember, when in the tube where you were taking enzyme extract and you were taking sucrose as a substrate, the readings were not increasing, they were constant. They were just 0.4, 0.4, 0.4, 0.5. And that is all the background values. That's all coming from your potato extract. It is not because of any reaction being catalyzed by tyrosinase, because sucrose is a non-specific substrate for tyrosinase. So we studied specificity of the substrate. So this experiment showed us catechol is a specific substrate, and sucrose is non-specific. So this is what we tried to study in experiment number 1. Is that clear to everybody? Okay. What we did in experiment number 2?
That tested the effects of pH and salt.
Second experiment. Experiment number 2. The very first day. We did two experiments the very first day. What we studied in experiment number 2?
The concentration of catechol.
Concentration of?
Catechol, different concentrations.
So what we try to study, we try to study the effect of substrate concentration. The effect of substrate concentration on enzyme activity. Okay. So when you write, your language should be very clear. Okay. A lot of people don't know how to write. So in second experiment, effect of substrate concentration on enzyme activity. So be clear in your mind, we are studying enzymes, and we are studying its activity. So in second experiment, you have tried to study the effect of substrate concentration on enzyme activity. And in this experiment, what you did, you had done the serial dilutions of 0.6% catechol. So you have taken 0.6% catechol, 0.3% catechol, 0.15% catechol, 0.0725% catechol, whatever it was. So in second experiment, you have tried to study this effect. And what you have done in experiment number 3. What we have done in experiment number 3? Effect of?
pH.
So we studied effect of pH or salt on enzyme activity. So please, everything should be clear in your mind, because only then you can write well. Okay, so we have been trying to study the oxidation of catechol, and which is catalyzed by tyrosinase, and the end product is quinone, which is brown in color. The more product you get, which means there's a more enzyme activity, and the way to detect the brown color, we have used spectrophotometer, and the values we were getting, those values are of the absorbance, because more molecules of quinone, they will be absorbing more and more light. You get more absorbance values. Less molecules of quinone, less absorbance values. So the amount of product formed is directly proportional to the enzyme activity, and it's directly proportional to the absorbance values you're getting. Okay, so these were the 3 experiments we did. Now we're going to discuss how you would write lab report. Okay, so the format of writing lab report is similar as your nature of science, because this is a format of doing either scientific presentations or writing scientific documents. So basic format remains the same, but in this lab report, you don't need to break into the way we did, like broke the experiments, and because in the first lab report, the experiments were sequential, which means you got some results, you make the second experiment. Whatever you got in second, you proceeded with the third. So, but these experiments are not like interlinked things. So in this you can write down everything together. So basically the first page is going to be title page. So first page is title page. So which means that you need to come up with a title. Okay, so these are the 3 experiments you have done. So it was a project, it's a mini project. So you need to come up with a title. First thing is title, then name of the group members. And third is the instructor's name. So these are the 3 things which needs to come on your first page. And first page is going to be devoted only on title. So you're not going to write anything else here. Okay. So this is your title page. After that, you can go to your second page, which will involve your introduction. So in the introduction, there will be 3 things. 3 things are required. Number 1, you have to give brief description of the subject, and the subject is enzymes. You are going to write 1 or 2 lines on enzymes in journal, then you have to write specifically about tyrosinase. 1 paragraph, in 1 paragraph write 2-3 lines on enzymes in journal, 2-3 lines on tyrosinase, because this is a specific enzyme we are working on. Second experiment, second paragraph, you have to briefly describe your project. You have to briefly describe your project, not more than 1 paragraph. So all the things you have done, you have to briefly describe. And another important thing to remember, please write in past tense, because this is already done, you are reporting that. Don't write we will do that, is going to do that, he is going to do that, she is going to do that, she is going there, she is sitting there. This is not scientific writing. This is storytelling. You have to write scientifically. The experiment was performed, this was added, this much, 100 grams of potato was weighed, 100 grams of potato was blended with 100 ml of water, like that. Don't write he did that, I did that, no. And everything has to be in past tense, because you are reporting something, you are reporting the project, it has already been done. It's not going to be done, or you're not doing it right now, it's done. Use past tense. Briefly describe your project. Third part is your hypothesis. So you have to give hypothesis. There are 3 parts of this experiment. You have to give hypothesis for every part. Okay, just 1 line. There's no need to write stories on hypothesis. You don't need to write that. Just 1 line for every part. 3 or 4 lines, make 1 paragraph. So this is what I'm going to look for in the introduction. Anything which is missing is going to deduct your points. Okay, this is basically a kind of a rubric. So for in introduction, first of all, brief description about enzymes in general, 1 or 2 lines. Write about tyrosinase because this is the enzyme you are working on. Second, briefly describe your project. And third is the hypothesis. This is all required in introduction, not much. And also don't forget, in the introduction you have to give references. So when you are writing something about enzymes or something about tyrosinase, you are not saying these things from your mind, okay? You are taking these things from somewhere. So you have to refer. You have to support your statements with the references. And you know how to write the references. You have to write the reference in parentheses. And in the end, you are going to give the complete reference in the end, in the list of the references, which is at the last page. I have already posted the document which gives you the instructions how to write this enzyme lab report, and it tells you how to write the references, how to write a reference for a journal article, how to write a reference for your book chapter, for a website, for a lecture. Okay, the format is given there. Use that. It's already provided to you. So your references, you have to use some references in the introduction. Is everybody clear with this? Okay. Next part is your material. So in the material, basically you just need to give a list of all the stuff you have used. You use beaker, you use cuvettes, you use spectrophotometer, you use potatoes, you use ice, you use beaker, whatever you have used, just provide a list. And you have to give the list of all the 3 parts together now. We are not splitting 3, you can write down, you can just sit down and think what you use for first experiment, what you use for second, compile your list and give it here. Okay? So in this lab report, we are not dividing into 3 parts, it's all together. Material. Okay, then will be your methods. And for all these parts, you have to give these headings and they should be bold.
For the materials, will we do like a paragraph or we can just list them there?
For material, I prefer a list.
Okay, we just
It's
list
easy
them
to for anybody to read.
Okay.
If you write in a paragraph, like you write beaker, comma, plate, comma, this, comma, that, it's not wrong. That's a correct way of writing. But I think it is better for anybody to read if a list is there. So that is a preferable way of doing that. Okay, next is methods. In methods, you have to give detailed protocol. So detailed protocol means you have to give all the volumes, all the weights, each and everything. And for writing methods, you can take help of your lab manual. In the lab manual, everything is given. And don't forget, in the lab manual, you were given some tables. Like for your first part, you were given a table where it was written how much you're going to add the enzyme extract, how much you're going to add the catechol. So basically, you need to insert that table into your methods. Now you don't have the digital, so you can just click picture with your phone, make it digital, and you can insert that in your document. Okay, so if you see your lab manual, the tables are given which tells you how to make it is on page number 43 and 44 or 45. It's I think 43 and 44. So the tables are given there. It was very well stated there how you are going to make different tubes. How much enzyme extract you're going to add, how much catechol you're going to add, how much sucrose you're going to add. In this tube, you're just adding substrate. In this tube, you're just adding enzyme extract. Everything is given. You need to have this table in your material, methods. Okay? It's not that you will just give the table and everything is done. You need to describe also, basically, how you made the tubes. But this table you have to give. You need to describe also. So for your substrate part, for your second part, you have to show that picture where how to do the serial dilutions like this. It is again a picture in your lab manual that how you did the serial dilutions. Again, click the picture, make it digital. Insert in your document. So there's a picture how you did the serial dilutions. That also is required in methods. Okay. So methods you have to write down how you did things, and you will be adding these tables and these pictures from your lab manual. Everybody clear? Okay, proceeding to the next part is your results. Now, for the results, always remember, lab report is very defined, which means that there are different parts where you have to write different things. Don't overlap things. Results is only results. It means you are going to give your observation or your data. So in results, there are three things which you need to include. You need to describe your results in words. Whatever your observations were, you have to write in your own language. And then you have to provide a table in which you are going to give your raw data. You know what raw data is? The absorbance values you got. Okay? You have to provide a table with the raw data. So the absorbance values which you have noted down from the spectronic over the time, how much was the value in 30 seconds, 60 seconds, whatever. So here you're going to provide that. And third thing, you're going to make line graphs. Now what are line graphs? For making line graphs, what are you going to do? You are going to take on the x-axis, you will be taking time, because time is your independent variable, and on the y-axis is going to be your absorbance values. And you are not going to make one graph for every tube. So for your experiment number 1, where you have tried different things, you have used just substrate, just enzyme extract, then you had enzyme and substrate both, then you had sucrose and enzyme. So all those things you will be showing on one graph. So which means that you will be having 3 graphs. Okay? You need to have only 3 graphs, because if you separate out things, we cannot make comparisons. So like for example, for the first experiment, the tube where there was just the substrate, the values were very little. So all your values are going to be here, right? And second tube where you had enzyme extract, your values may come somewhere here. Third tube where you were taking both the enzyme and the substrate, maybe you will get a line graph like this. And you can actually take the tube number 3rd and 4, you can take the average of them and just plot this one, because 3rd and 4 are same. There were 2 tubes, I don't know exactly the numbers, but there were 2 tubes where you just did in duplicate, where you have added both the enzyme and the substrate. You can take their average and plot here. And your last tube was where you have taken sucrose instead of catechol, and your values must be low and they should be somewhere here. So all these things you need to show on one graph, because you need to show comparisons. You have to show how the reaction is proceeding when you are using catechol and enzyme, how the reaction is going on when you are using sucrose, because that's a non-specific substrate. You need to show how what happens, what values you got when you use just the substrate, when you use just the enzyme. You need to show everything on one graph. Only then we can make comparison. Suppose you show sucrose on one, catechol on another. Then how do we compare, right? We need everything on one graph. So you will have 3 graphs like this. Like in the second experiment, so you will be having, like for the first part, you can make paragraphs, like to describe your results for the first part, give the table, and then make one line graph. Then in the second paragraph, you can start discussing, like if you want to use 2 paragraphs for describing the results, that's also okay. So in the new paragraph, you start describing the results for your second part, which is your substrate concentration. So for that, you will be making again, you will be describing them, you will be giving them data, you will be making line graphs. Now you had
so we're gonna have the table on our paper twice.
table.
The tables, because
You will have 3 tables.
3 tables.
Because there are 3 parts, right?
Mm-hmm.
In the results part, you will have 3 tables.
Then in the material part, we still have the tables there.
Method part. Material is just a list. In the method part,
the method part.
in the method part, you're just going to tell how you made the tubes. It's just how you made the tubes. It does not involve your readings.
Okay, no content in it.
No, because that should be in results. The data is going to be in the results. In the method part, it will be just, you will be showing how you made those tubes. So you can make use of a table. So for your substrate part, like you used 4 different concentrations of substrate. So when you were decreasing the substrate concentration, the values were decreasing, right? So in one graph you will show, like your graph is going like this with 0.6%, with 0.3% it's like this, because it should reduce, right? And with it's going, it should go like this. So if you make all these things in different graphs, then how do we compare? So you have to show the effect of substrate concentration on one graph. And similar is for your last part. If you have seen the effect of pH, you have to show everything on one graph, how the graph was going when you used neutral pH, how it was when you used acidic, how was it when it used basic. So whatever the results you have got, just plot that. Okay. So this is the way you are going to write down in your results. So your results will have 3 tables, 3 bar line graphs. Plus you need to describe your results, whatever results you have got. After the results is your discussion. Is everybody fine with the result part? Yes. Okay. After this is your discussion. Now in the discussion, you need to discuss your results, which means you have to discuss why you are getting these kind of readings. So you will discuss your results. That's number 1. And number 2, you need to do a research. You need to go online and you need to check if somebody has done similar kind of project. You guys extracted tyrosinase from potatoes. Tyrosinase is present in some other fruits too. It is in apples and some other fruits. Just go online and see if somebody has done similar kind of experiments but extracted tyrosinase from some other source. Or you can go online and also check if somebody has worked on some other enzyme. There are a lot of enzymes, amylase, lipase. Go and check if somebody has done similar kind of study with a different enzyme. And then make comparisons, what kind of results they got, did they get same results as you. So make comparisons and give references here. So when you discuss some other group's results, you need to give references, right? Because that is going to support it. Yes.
Can you use one of the lab partners, their results as comparison?
No. That's the same thing. No. You need to go do research. That's exactly same experiment what you have done. No, you cannot do that. So your references, when you go online and you come across some studies and you report those studies, when you're writing something about some other groups, you need to give a reference. Okay? So if anybody is reading your project, they should be able to go and confirm if somebody has actually done that. Or if somebody is interested in somebody's work, and you need to give a full reference. So that you will give a reference here in parentheses and a complete reference in the list of the references. And then you need to think about if there were some errors in the experiment and how you can improve them. So these are all things which are going to be included in discussion. Okay. So when you're going to discuss, in the very first part, when you're going to discuss your experiments, so in the first part, basically, you are going to discuss like when you added both the enzyme and the substrate, your reaction was initially proceeding and then it levels off, right? So you need to discuss why it's leveling off now. So what do you think? Why it was not increasing after some time?
It's constant.
Why it's constant?
Because chemicals it's constant.
There's no more.
That's what I'm saying. You are going to write down that you have already written in results that the enzyme reaction was proceeding, it was increasing, you were getting quinone, and after that the absorbance values become constant. When they become constant, you are going to show this kind of a plateau in the graph. Now in the discussion, you need to discuss why are you getting to this. That's what discussion is about. So what do you think? Why it's becoming constant?
There's no more substrate.
Enzyme is saturated. Yes, enzyme has active sites where substrate goes and bind. After some point, all the active sites of enzyme are occupied. After that, this reaction cannot proceed.
That's equilibrium, right?
Huh?
That's equilibrium also, right?
Pardon?
That's the equilibrium, right?
This is a plateau. We call it in a graph a plateau. Yes. After that, the reaction doesn't increase anymore because all the active sites of the enzyme are occupied by the substrate. So the enzyme is saturated. And one thing you need to discuss this, and second thing you need to discuss in this experiment will be the specificity of the substrate. When you were using sucrose, the values were not increasing, right? They were just background values. I think that those values you even got when you were just using the enzyme extract. So that is nothing, it's not a value from product, it is basically a background value, which is coming because of that potato color. So there was no reaction when you were using sucrose as a substrate. So here you can discuss that sucrose is a non-specific substrate for tyrosinase and catechol is a specific substrate for tyrosinase. That is the point you need to discuss. These are two important points you need to discuss. I will be looking for these. If you don't write, I'm going to deduct points.
You have to explain why. You have to explain why.
Yeah, that's what discussion is about.
Okay.
Yes.
It's just like the active side, it doesn't fit.
Yes. That is what discussion is about. Discussion is about your insights. Discussion is about your understanding. It reflects how much deeply you understand your project.
That enzyme.
So discussion should be written in your own words. That's why I'm emphasizing on your understanding of the experiments. Because
So
if you don't understand experiments,
It's basically chapter 6, right?
Huh?
It's basically chapter 6.
less enzymes
there's everything there. Then you can take the help of that. But write in your own language. Don't cut paste. Write in.
Because it's sort of like a
No, I said like in the first experiment, you need to discuss two things. One is the saturation of the enzyme. Second is the
people
specificity of the substrate.
bring in
And for your experiment number 2,
or he has a
for
passenger
your
like-
experiment number 2, you have to discuss when you were decreasing the substrate, the values were coming down. Why? Because there's less substrate available, right? When there's less substrate available, the reaction will be less. So you need to discuss here the effect of substrate concentration. If there is more substrate available, the more active site of the enzyme will be occupied. If there is less substrate, less active site. So the reaction will be slow, will be less. So you need to discuss this point for your second part. And third part is about pH and salt. So the people who now different people tried different pH and they tried salt. So basically, if the pH is very acidic or it is very basic, then the enzyme gets denatured, right? So you have to, if I think around pH 2 and around pH 10 or 11, the enzyme was totally gone. It was not working. So you need to discuss that at these pH, but at some pH like 3 and 4, it was still active. So which means that it was not totally denatured at that point. So whatever the results you have got, because everybody got little different results. So just go and see your results and understand, is there any enzyme activity there or not? If there is not, which means the enzyme is totally gone. If there is some activity, you have to write maybe some enzyme. This enzyme is, its optimal pH is neutral basically.
There's some inconsistency in my data. Should I make note of that too?
What I would suggest, I'm giving you 2 weeks time to write the rough draft. So whatever the data you have, please make your graphs. Okay, then give it to me, I will give you my feedback. If I think your data is absolutely wrong, then I will ask you to take the data from somebody else. Sometimes you feel your data is wrong, but it's actually not wrong.
Yeah.
Like if you think, oh, pH is 3 and my enzyme is still active, which means maybe at this site pH the enzyme is totally not gone. It's pH 2, maybe. So write down your rough draft with whatever you have got, and I will see your data, and then I will give you my comments. If your data looks like there is some experimental error while you were doing, then I may ask you to take the data from somebody other group. Okay, but if I feel experiment is done fine and the data is like that only, so then I will ask you to keep the data. Okay? So right now, don't try to get that, don't change the data, don't manipulate anything. Whatever you have got, just do your work.
Okay. So when we graph like everything on one graph, should we change the color or label it?
Yes, definitely.
Okay.
When you are going to show 4 things or 5 things on one graph, you have to distinguish them, right?
Okay.
You can use either different colors or you can use different symbols, and you have to tell what is what. So
How many references?
3 to 5. So you guys have 2 weeks time to write the rough draft, and you are again going to